What is pre-stressed concrete? Pre-stressed concrete is a method of applying pre-compression to control the stresses resulting due to external loads below the neutral axis of the beam. Using high tensile strength steel alloys producing permanent pre-compression in areas subjected to tension. A portion of tensile stress is counteracted, thereby reducing the cross-sectional area of the steel reinforcement. Types of pre-stressing: post-tensioning and pre-tensioning.
Post-tensioning. In post-tension, the tendons are tensioned after the concrete has hardened, commonly metal or plastic. Ducts are placed inside the concrete before casting. After the concrete hardened and had enough strength, the tendon was placed inside the duct, stressed, and anchored against concrete. Grout may be injected to the duct later. This can be done as precast or cast in place. This is an example of post-tensioning. Here is the tendon, which may be made up of metal or plastic. And this one is the anchorage, which also called the dead end anchor. This will be anchored to the concrete on the other side to produce the tensile strength. And after that, grout may be injected into the duct. Here is the grout. Next is pre-tension. In pre-tensioning, the tendons are tensioned against some abutments before the concrete is placed. After the concrete hardened, the tension force is released. The tendon tries to shrink back into its initial length, but the concrete resists it through the bond between them. Thus, compression force is induced in the concrete. Pre-tension is usually done with precast. Here's an example of pre-tensioning. These are the beams. Let's call it beam 1, 2, and 3. This is the cable or the tendon, which is anchored here to be fixed. To be fixed, that when the jack here is used, this is where the tension strength will come. After the jack is used, it will be applied tensile strength, and the compressive strength in the concrete as it hardened will be strong also. And here is the abutments. This is abutted in rocks, and here is in soil. Just to compare.
Advantage: post-tensioning allows longer clear span, thinner slab, fewer beams, and more slender dramatics elements. Post-tensioning can thus allow a significant reduction in building weight versus a conventional concrete building with the same number of floors, reducing the foundation load. It can be a major advantage in seismic areas. Another advantage of post-tensioning is that beams and slab can be continuous. Single beam can run continuously from one end of the building to another.